Now let's continue our discovery of new rules of differentiation, and the next one would be the quotient rule. So given f and g are differentiable functions at x and and g of x is not equal to 0, then the derivative of f divided by g is equal to f prime g minus f times g prime divided by g squared. Now let's see how we can use this rule to find the derivative of a function. So d dx of e to the x over 1 plus x squared. Okay, so we say that f is e to the x and g is 1 plus x squared. Now, by this rule, we need to first find the derivative of f and times g. And so we would have e to the x that stays as e to the x when we take the derivative of that, and times 1 plus x squared, which is my g, right? So this is my f prime, this is my g. Now, minus f times g prime, minus f is e to the x, and g prime is going to be 1 becomes 0 plus x squared becomes 2x. And now we need to divide that by g squared. So g is the denominator, 1 plus x squared, and that is all squared. So again, this is my f, and this is my g prime. And this is my g squared. So now if I simplify it, I have e to the x times 1 plus x squared minus e to the x times 2x. So I'll just put 2x e to the x over 1 plus x squared, all of that squared. And then you can either factor out e to the x or leave it as is. Doesn't really matter. And this is how we use the quotient rule. Now let me show you another example. Let's say we have a function 3x cubed plus square root of x over x squared, for example. So I want to find the derivative of this function. Again, my f is 3x squared, sorry, 3x cubed plus x to the power of 1/2, and my g is just x squared. So now, by the rule, I will need to multiply, so let me write that again. D dx of f over g is equal to f prime g minus f g prime over g squared. So f prime is the derivative of the 3x cubed plus x to the power of 1/2. So I would have 9x squared plus 1 over 2x to the negative 1/2. That's all times, okay, let me move that, times g, which is x squared. Now minus f times g prime. So f is just 3x cubed minus x to the power of 1 over 2 times g prime. So the derivative of x squared is 2x. All of that divided by g squared, which is x squared squared. So now let's simplify it a little bit more, and we have 9x squared plus 1 over 2 square root of x in the denominator times x squared minus 3x cubed minus square root of x times 2x over x to the fourth. And we can simplify it a little bit further, and we have 9x to the fourth plus 1. So we have x square root of x, and in front we have 1 over 2 minus 6x to the fourth plus 2x square root of x over x to the fourth. Now you can continue simplifying it even further. We can probably do something with x's, but I will just keep it as is. And now we looked at the example of power rule having the fraction in the power as in examples of square root of x. Now let's look at the example when our x is in denominator to apply the power rule. So let's say I have 2 over x, let's say to the third power. So I want to find the derivative of that, but without using the quotient rule. What I can do is I can bring this x to the third power to the numerator, and I'll have d dx of 2x to the negative third power, right? So in this case, I can treat this negative, I can use this negative 3 as an exponent and bring it down and reduce by 1. So watch what we will have. So 2 times negative 3 times x to the power of negative 3 minus 1. So we have negative 6 times x to the power of negative 4. And if we simplify it even further, we have negative 6 over x to the fourth power. Now let's look at the example of the derivative of a well-known function, 1 over x squared. So in this case, we will have d dx of x to the negative second power. So now I'll just take this negative 2 to the front as a coefficient and reduce a power by 1. So I would have negative 2x to the power of negative 2 minus 1. So I have negative 2 times x to the power of negative 3. And to simplify it even further, I have negative 2 to the, divided by x cubed, and that would be the end of the problem. Thank you.